Well, many thanks for joining our webinar today. I'm joined by my colleagues Natalie Wood and Philip Cosgrave, and we've actually titled the webinar Nitrogen Price, How Does It Affect You? And really that is clearly an important issue right now as to what you have or are paying for your nitrogen in terms of how you then really maximise and that return on investment. So we're going to go through both the arable side of things with Natalie talking about how we respond to the pricing of nitrogen on the arable crops, and then we'll follow that straight on to Philip going through how to respond by way of the grassland crop. But before we do that, I'll just go into a little bit of background just to set the scene, because I think it is an important one just to get some clarity around. And what you'll see on the screen there is that I have put up the manufacturing process, because when the real nitrogen price started to accelerate, there was a lot of discussion around CO2, and it was pretty much, or you certainly wouldn't be wrong to think that actually CO2 was the main product and that the fertilizer was the byproduct. But just so we're clear, when it comes to manufacturing nitrogen fertilizer, there's one key bit in the manufacturing process that you can see on the screen there, and that's the ammonia. And how do we get to that ammonia? Then we use our nitrogen from the air, and then we need a source of hydrogen, and we take that, depending on the process, either from natural gas or coal. Most European production is going to be from natural gas, and that's why the gas price, which you would have all heard about, and the way that's accelerated, is so fundamental when it comes to the production costs. So what we saw over the period of days and weeks was an accelerating natural gas price, going through from sort of 5 to 10 to 12 to 20 to 52. And as it did that, then at times there was 200 euros per tonne going on the production cost of fertilizer, so giving manufacturers real problems. Not only have you had that rising gas price, but you've also had then a level of protectionism coming in as countries around the world really want to protect, if you like, themselves against food security. So you're starting to see whether it's China or Russia bring in measures to restrict exports, which has put also then fears into the marketplace in terms of that continuity of supply, and will the various agricultural sectors around the world actually get enough fertilizer? So putting a further pressure into the system around supply and demand. So you've had that perfect storm of political, economics, commodity pricing all coming into play to give the background as to where we are today. So that gives you the background. We're now going to really move on to think and bring it to that sort of rational argument around how do I make best use of the nitrogen fertilizer. So I'm going to start and hand straight over to Natalie Wood to take us through that, the arable crops and how we might react.
Thanks, Mark. Yeah, so I'm going to cover how fertilizer pricing affects your nitrogen rates and what else we need to think about to increase efficiencies come spring. So if we start with winter wheat and we take a look at some of our long-term data, this is data from 2006 to 2021. We carry out these end-dose response trials each year to build average data across several sites and several seasons, so that we've got robust, reliable data for calculating things like optimum N rates, etc. So here we've got the data you can see here to plot the average results from those last 15 years at 7 different nitrogen rates to get the typical N response curve that you can see here. So from this curve, we can see that the response to nitrogen is strongest, giving us the best return on investment. And where it starts to plateau there, you're getting less of a return. So what we're looking at is that first part of the curve there. And we can break it down really into 3 different brackets. The first 100 kilos of nitrogen gives us, by far the best response. You can see from the table that we've got 2.76 tons per hectare yield increase, which is 28 kilos of grain per kilogram of nitrogen. The next 60 kilos, which is taking us up to 160 kilograms of nitrogen in total, has increased the yield by 0.77 tons per hectare, but this means the kilograms of grain is less than half of that of the first 100 kilos of nitrogen at 13 kilos of grain there. And then we've got that final 60 kilograms of N, which gives us that 0.38 tons per hectare there. So, ordinarily we would push for that extra bit of yield at the end, that smaller response, because the return, whilst it is lower, is still a return on investment. But what with prices as they are, that might now change your decision. So if we head to this next slide, this is looking at 3 different buying times: early, 50/50, and the late buyer. And what we're looking at here is the margin over nitrogen cost for those 3 buying times. So if we start with the early buyer, who say bought in, June, July, paid £280 a tonne, you can see that the best margin is coming from that standard 220 kilograms of nitrogen rate, which is about the optimum normally. So therefore, no real change is necessary for this buyer. You can still push for yields and take advantage of crop prices. If we look at the 50/50 in the orange, then you can see we use the average of the 2 prices there. So if you have bought some early, some late, you need to look at your average price to be able to work this out. You can see it's still, the margin's still highest at that 220 rate, but also there isn't much difference between that and the 160 kilo rate. So therefore, looking at this, you'd probably go for, say, 280 to 200 kilograms in this particular scenario, so that you're in between those 2 rates there. Now, if we look at the late buyer who's bought at, say, 680 to 700 pounds, you will need to think differently. You can see that the 160 kilograms of nitrogen per hectare rate is now the best margin. So, of course, prices have come back slightly recently, so therefore you might want to go up to the 180, but certainly you do not want to go any lower than that 160 kilos of nitrogen. And that's that circle there. So, once we move into the spring, we can reevaluate the crop and the fertilizer prices, and obviously the crop's potential, to see whether it's worth topping up with some nitrogen later on in the season. But for now we can look at this scenario, and we can use various tools, some of which I'll speak about a little later on. So if we do the same now for spring barley, we have some data spanning the last 10 years. And you can see here the first 80 kilograms of nitrogen per hectare gives that best response again on the curve, increasing the yield by 3 tons per hectare, which is 38 kilograms of grain per kilogram of nitrogen. And then the next 80 gives a response and a return on investment, but it's 0.86 tons per hectare yield increase, so similar to the winter wheat in terms of the response. And then you can see it starts to plateau. If again we look at the 3 different buying time scenarios, then you'll see a similar story. If we start with the early buyer, then you can see 160 kilos is the optimum here for the margin. If you bought 50/50, then again 160 is still giving you the best margin. However, if you look at the late buyer, then the best margin drops down to 120 kilos of N. But you can also see, it's a very close margin to that 80 kilos of N, so therefore you would want to be somewhere in between that 80 to 120. So yeah, and just to note, these are trials done on feed barley, so of course, the rates will differ if you're targeting specific grain nitrogen percentages, but this is purely looking at yield for these trials. If we think of oilseed, then the advice doesn't alter too much from a normal year in terms of you want to get that green area index to 3.5 for that optimum nitrogen rate. What we're looking here is at a nitrogen source trial that we did. So obviously we've talked a lot about nitrogen, but this trial was looking at an NPKS grade, which you can see is the extra grass there, as opposed to the straight nitrogen, which is below. So when we talk about increasing nitrogen use efficiency, it's not just nitrogen that we're targeting, so it's all the nutrients. And you can see here that by the addition of those extra nutrients, we've got a much better yield, and it's been more efficient there. So in terms of why that is, I'll go into that a little bit later. But as I've said, we've got M, P, K and S being applied here little and often through this season, which is what's given us those efficiency increases. So in a year where nitrogen rates are reduced, the use efficiency of nitrogen and other nutrients is even more critical, to get the most out of what we can apply. So there's many ways that you can start to increase nitrogen use efficiency, but I'm going to cover a few of them here, including sulfur, and that's our main nitrogen sulfur grade there, Axan, as well as some of the tools. So you can see the handheld device, which is the N tester, the tractor mounted N sensor, and then the last picture is the map that you will get in at farm. So we've covered, the importance of sulfur in previous webinars, so I'm not going to, go on about it too much, but just a reminder that sulfur is a very important part of nitrogen uptake and utilization. So if sulfur is deficient, even slightly, it will start to affect the plant's capability of utilizing the nitrogen that's been applied. And this is why it's so important to include sulfur with each nitrogen application by using, as I mentioned there, an NS compound product like Axan as opposed to straight nitrogen. And this was some work that we did on a sulfur response trial where we had Axan versus straight nitrogen there. And you can see the addition of the sulfur has given us 1.4 tons per hectare yield increase. They've both had exactly the same amount of nitrogen, which is the 220 that you can see at the top there. So that addition of sulfur has given us that yield benefit. And if we look at wheat prices today, say at £208 a tonne, you are getting £291 per hectare there from that sulfur application. So of course that is a very good response. We don't always expect to see nearly 1.5 tonnes increase. So this was a trial that we did back in 2020. And you can see here we've got a 4% yield increase from sulfur at this site, and you can see there was 2 applications of Axan followed by the straight nitrogen there. Again, the N rate was 220 kilos of nitrogen. So therefore what we're trying to say is applying sulfur little and often with your nitrogen increases the yield and the nitrogen use efficiency, which is going to be key this spring. If we think of another tool that's available to us, then variable rate nitrogen applications are one of those. If we look at this small graphic here, you can see these are the different N dose response curves that you might get, the N response curves that you might get across a field there, just to show that the variability. So some of the steeper curves are getting a better response, some of the flatter curves you're not getting a very good response, but without monitoring that you wouldn't know to look at the crop. So by using variable rate applications, you're applying nitrogen to the areas that require it and supplying that crop with what it needs, increasing the nitrogen use efficiency, and then in the other areas you're boosting the yield in, say, the poorer biomass areas. And potentially your overall should be decreasing wasted nitrogen, basically. You're decreasing the amount of nitrogen on the lush areas, so that there could be decreased nitrogen spend, but what we're really after is this even homogeneous crop there. So obviously the field on the left-hand side has had a application with an N sensor, and you can see there how much it's evened that crop up. So this means the benefits of less lodging, easier harvesting, and basically just increased efficiency overall. If we look at some of the background behind the N sensor, then most systems use NDVI to calculate the biomass for nitrogen content, but this can be inaccurate at some of the later growth stages due to the saturation effect. With the N sensor, it uses different wavelengths, which gives a much stronger correlation of 0.94, which you can see on the graph on the right-hand side at the bottom, compared to 0.76, which is on the left that you get from NDVI alone. So this makes the Nsense still, the most accurate real-time sensing technology on the market, really. How it works is once the Nsense has that reflectance value, it's able to calculate the amount of nitrogen required as it travels through the crop. Again, meaning, real-time variable nitrogen applications as it goes through. So we're evening up the crop, reducing the lodging, and making combining much easier. And you can expect on average, say, a 4% yield increase from doing variable rate nitrogen applications. If we think of @Farm, which is our web-based software, so within that we have other tools for increasing nitrogen use efficiency, such as the N-Tester. The N-Tester Bluetooth now runs through @Farm, and you can see that's that handheld device there. The N-Tester, it measures the amount of chlorophyll in the leaf, and this directly correlates to the amount of nitrogen, and it will then calculate how much nitrogen the crop requires. This can often be less than you'd think, but what I'd say is trust the device. If it's telling you to put on less than you think, that's the way that you are increasing your nitrogen use efficiency, because that device is telling you what's in that plant at the time. So yeah, best piece of advice would be just to trust the device. And if you're using tools like this, you can get your nitrogen use efficiency up into the high percentages there, 80%, for example. Another way that you can use the N-Tester is as a reference value. So it will give you a 3-digit reference value when you test the leaf. And with this, you can start to monitor that value. Once it starts to drop below a certain level, you know that the timing is right for applying some more nitrogen, which is another way of increasing your efficiency, because you're only applying it when the crop requires it. The map at the top there with the dots on, this is variable rate applications, but within @Farm. On how @Farm works, it uses satellite imagery to get NDVI, but as well as the NDVI, it also uses some of the values from the N sensor. So it gives you a much more accurate variable rate than just NDVI alone from satellite imagery. And you can see there, it will give you that map showing the different rates of nitrogen across your field. I mean, it's also a very good way of monitoring crop biomass as well throughout the season. So really, it's about using as many of these tools and things as we can this year to increase that nitrogen use efficiency and get the most out of what you've paid for your fertilizer. I'm going to hand over now to Philip, who's going to talk about how it will affect you within the grassland sector.
Thank you very much, Natalie, and hello to everyone listening. I'm going to cover the grassland side of this presentation, and how does current fertilizer prices affect you. And in the next number of slides, I'm going to cover the contribution of fertilizer cost to the overall variable cost on dairy farms, looking at some nitrogen response work, and also what happens if we decrease our first cut end rate. Tendency that first cuts are probably the most important cuts that we make, and I suppose there will be some farmers looking at with the current price of fertilizer that they may be looking at reducing that rate. So what's the impact of that on the overall cost on a per ton of grass produced or grass grown? And then just to finish up with some main messages, but I'm covering within those messages some efficiencies we can bring on farm to lower possibly the amount of mineral fertilizer we need, but also getting the most of organic manures, but also not just looking at just nitrogen itself, but crops require more than that. They require phosphate, potash and sulfur applications at the right levels. So unfortunately, this is only for dairy systems. The graph on the left-hand side is a graph that's just recently been published by AHDB, and the table on the right-hand side is some work from Teagasc Profit Monitor farms, dairy farms, from 2019 and 2020. So I'm just looking to give you an overall, I suppose, view of what does the cost of fertilizer, what does it represent, and overall the variable costs on dairy farms. So we can see in the AHDB, so this will be UK information. This is back from 2018 data. We can see there that from all year round herds and autumn calving herds, there's around about 5 to 6% of variable costs are attributable to fertilizer. But then as we see, spring calving herds, the actual percentage of variable costs is close to 11%. And this is, I suppose, you'd be surprised, but I guess with all year round and autumn calving herds, there's a lower amount of the overall diet in those systems coming from forage. So it's not really a true reflection of the fertilizer, because there may be, obviously, purchased concentrate will have fertilizer applied. So those, I suppose, the fertilizer costs on those farms are kind of lower than what you might think. But whereas in spring block calving herds, more of the actual diet of those cows is going to come from grazed grass in particular, so more of the forage. So you're looking at, probably over 4,000 litres is going to come from forage with those cows, and cows that are of annual yields of maybe 5,500 litres. So, and more of the I guess growing grass without high levels of concentrate purchase feeds is resulting in that higher proportion of variable costs coming from those spring block calving herds. And you can see that's kind of reflected then in the Teagasc work on the table on the right hand side, where over the years 2019 and 2020, taking in fertilizer for both those years, variable cost fertilizer came to about 90% of variable costs on those farms. So the more forage, the more grazed grass we're using in those diets, the greater the impact of the increase of fertilizer. But I think in generally where we see concentrate feeds are increasing in price as well. So any of if it's not just going to be on that grass, but our purchase feed, typically AHDB put out that about 30% of the overall cost in producing milk is coming from feed. So it's not just fertilizer increases, but it's all going to come from an increase in the cost of purchase feed. And it's important for us to then look that those farms that are growing more grass are going to be, it's going to impact them more. But if we're looking at nitrogen response, Natalie put up some very good graphs there on some of the main arable crops from wheat, barley, and oilseed rape. From grass, I suppose there's going to be a different thought process going through a grassland farmer's mind, because in generally some farms will have will have scope to reduce stocking rates if they're a system that that is fattening beef animals, for example. They may make a decision that they will fatten less animals next year off grass, for example, or keep less animals overwintering for the 2022-23 winter. So there will be some option for those farmers, but for the most farmers who are dairy farms and suckler beef farms, they will not want to reduce stocking rates to reduce grass demand. So what kind of responses to applied nitrogen are we getting? And most of the work on nitrogen response is being done from just mineral N, and it's not using a combination of both mineral N and nitrogen from organic sources. But if we look just from the work from Hurley back in the 1980s, and following all that work up in nitrogen responses on grassland, on both simulated grazing and silage up until the very present, and there hasn't actually been much of a change. But where simulated grazing, where grass is being cut in 4 weekly intervals, we're looking at a response to nitrogen of about 20 to 25 kgs of dry matter per kg of N. But on silage management, typically first cuts and up to 3 to 4 cuts, we're looking at a return of about 25 to 30 kgs of dry matter per kg of N. So for those looking that possibly in reducing the amount of nitrogen they're applying, they're good, I suppose, rules of thumb to look at what's the impact going to be on, you know, the amount of grass that I'm going to less grass that I'm going to grow from reducing my total N rates. If we look at grazing management, has a significant impact on the amount of grass grown per kg of N. So if we look at these two scenarios here of 10 tonne and 12 tonne, you know, generally grown with the same amount of mineral N. Now we're taking out of this, we're taking that 5 tonne of that 10 tonne is being grown from mineralized nitrogen. So in effect, for that 10 tonne, we're growing 5 tonne is being grown with the actual mineral nitrogen inputs. So that works out at around about 20 kgs of dry matter per kg of N. Whereas if we're growing on the same farm through maybe on geography, different parts of the country, or whether it's you know, improved grazing management, and this, you know, growing 12 tonnes of grass from 250 kg of N, and the same again, about 5 tonne of that coming from mineralized N. So you're looking at 7 tonnes of dry matter coming from that 250 kg of N. So therefore, you're getting more kgs of dry matter per kg of N, so 28 kgs. I know in AHDB publications, they look at 15 kgs of dry matter per kg of N, but I think in general that would be where there would be, you know, looking at less than 10 tonnes of dry matter grown. So these are good numbers to be kind of remembering, and how that this will impact on you know, on thoughts on lowering the amount of mineral nitrogen we're going to apply in 2022. So we can see in response graphs, compared to arable, particularly in winter wheat, it is more curved, whereas in grass the response rate is actually quite linear up to rates of around 400 kgs of mineral N, which is kind of not rates which we typically see now. So the next part of you know, the presentation is on, you know, the impact of a farmer reducing the amount on particularly first cut silage. It's the most reliable yield of any of the silage cuts during the year. So I suppose the first thing would be, it's worthwhile to remember that optimizing first cuts is you're going to get more bang for your buck by optimizing first cuts. But if we look at, you know, a farmer applying 33 meters cubed of slurry, plus then topping up with 99 kgs of mineral N, bringing the total up to 120 kgs of N, and growing around about 23 tonnes of grass. A farmer could expect to grow 23 tonnes per hectare of fresh grass with those rates on swards with good to very good growth potential, yield potential. And 33 meters cubed of slurry is the equivalent of 3,000 gallons per acre. So you can see on the bottom left-hand side, you can see where in kind of turquoise, the available N contribution from that 33 meters cubed of slurry is around about 21.5 kgs of nitrogen. And then as we look at the kind of the middle boxes, the same color in that turquoise color, we see that we're putting in the price of fertilizer. We're using Extran in this case at £700 per tonne. Now the cost there isn't going to really have a major impact to what I'm going to try and compare with the impact of lowering your first cut N rates. But the rate of N applied, that mineral N applied, we're applying 99 kgs of N to bring the total up to 120 kgs of N applied, and that's going to grow as 23 tonnes of fresh weight, or we hope that it'll grow 23 tonnes of fresh weight. So we see then on the right hand side, the boxes which I'll bring this up as so that you can see it better. You can see that the nitrogen fertilizer on a per hectare basis, the nitrogen fertilizer cost is £207 per hectare, and the total cost of growing that is £483. And if we look then, if we break that down to a per tonne cost, the cost of the fertilizer is £8.99 on a per tonne basis, or £20.99 for total costs. And there are two, I suppose, figures to remember, that particularly that £20.99 pence as a total cost per tonne to produce that silage. Not the per silage, but the actual grass, that first cut harvested grass. So now, if we change and we reduce the mineral N by 20 kilos, so instead of applying 79 kgs of N, we're now applying, or 99 kgs of N, we're applying 79 kgs of N. So overall, the total N is about 100 kgs of N per hectare, and at the same slurry rate of 33 meters cubed. Now, but the impact on that, and you'll see in the top left-hand corner, and it's highlighted in yellow, is that because we've reduced the N rate, we're not going to produce, as the yield is going to be less. So basically, if we take that rule of thumb that for every kg of N, you're going to grow 25 kgs of dry matter, and you work that up, that works out at 2 tons of fresh weight grass. So by dropping 20 kgs of mineral N, you're going to reduce your yield by 2 tons of fresh weight grass. But everything else will still the same. But we'll see on that box on the left-hand side what the impact of that is. So we can see that the cost of fertilizer reduces, obviously, because you're using less mineral fertilizer. The total cost will also come down as well. But interestingly, the cost per ton, and if we look at that total cost, the total cost per ton is pretty much the same at this reduced rate on a per ton of grass grown. And that's because you know, a lot of the costs associated with making that first cut silage are fixed. So there'll be obviously there'll be contractor charges, there'll be, you know, a slurry application charge, a fertilizer application charge, and then the actual silage making process itself. So that's because it's been the costs are a lot of those costs have stayed the same even with less of a yield. So basically the costs are being concentrated into fewer tons. So we can see there that there's actually no benefit in reducing the actual cost, because ultimately you're going to produce less silage, but that, you know, on the amount of the cost per ton of grass produced is the same. So farmers will need to watch this carefully. Now, if a farmer has a situation where they've a lot of silage in their clamp from this winter coming, well, then there's a decision to be made there about what the demand is going to be over the following winter, and maybe there is scope to reduce N rates. But it would need to be carefully considered reducing the N rate because of that dilution impact. On the dilution of costs on higher yields. So finally, just looking at some of the main messages, there is going to be a significant, you know, with what farmers are currently securing fertilizer at the moment, there is going to be a significant increase in cost of producing that grass. But just looking at ways of mitigating, now it's by no means going to offset all of the costs in you know, or increase in fertilizer costs, but certainly there is ways of mitigating some of those costs. And I suppose the first one would come to slurry testing, and that, you know, typically we're using book values for you know, the available N in our slurry. Now, book values are an average, so therefore that we can say, we can estimate that half of the samples are going to come in above that book value. So there is scope there that if our book value for 6% cattle slurry is 2.6 kgs of total N per meter cubed. So if you analyze your slurry and you get back an analysis, you may find then that there may be quite a bit more nitrogen in that slurry. So that will then allow you to lower your mineral nitrogen requirement, but at the same time not forgo any yield penalty. Also, optimizing spring slurry application rates, that by optimizing that slurry that you're applying in spring, say some farmers may tend to apply slurry on second cuts, you know, and have a lower amount of lower rates of application on first cuts. I would say that those first cut application rates would need to be looked at carefully, and there may be scope to actually apply some of that, you know, later applied slurry applications earlier in the spring, and that will, because slurry applied in the spring, there's a greater the total nitrogen is the availability levels are greater in it. So if you shipped for on a per cubic meter basis, by shifting a cubic meter from summer applied to spring applied, you're increasing the N availability by 2.26 kgs per meter cubed. Also, the slurry equipment being used, by going from a splash plate to something like trailing shoe, we can increase the availability per cubic meter by 0.1 kgs. So, you know, all of those are those, you know, marginal gains that can be made to reduce the overall mineral nitrogen requirement. The second or the third point would be on grazing, would be that first cut nitrogen applications on grazing are the most risky. So generally the actual return for every kg of nitrogen applied can be very low. It can be at 4 to 5 kgs of dry matter per kg of N, or that can go up to 15 kgs. So the point in spring is be careful where that nitrogen is actually being applied. Make sure that it's not, you don't apply a kind of blanket apply it, that you're looking at soil temperatures. So looking at parts of the farm that are drier, generally those parts of the farm will have drier, warmer soils, and looking at picking out parts of the farm, you know, that early nitrogen will work most effectively. So soils that are up to 5 degrees Celsius and those soil temperatures are increasing, that would be kind of the point at which some nitrogen could be applied. But instead of you know, going out with your typical first cut nitrogen application rates in spring, what you could do is you could have them to mitigate some of the risk of the weather turning poor then afterwards, because what typically can happen is you know, weather can turn poor, and then the question is is the nitrogen that I applied earlier still going to have an impact? So by reducing the amount of nitrogen you apply in that first application, split it will incur another application cost, but it may be worthwhile this year to actually spread that risk and apply some early, you know, when soil temperatures are just at that 5 to 6 degrees and rising, and then apply the second half when you know, when maybe 2 weeks later, 3 weeks later, when you know that risk is dissipating, because usually the later in the spring you go, that the weather is a little bit more predictable. And finally, on, you know, looking at, we're just talking really about nitrogen here, or what I've covered is just looking at nitrogen as a nutrient, but remember grass requires the other nutrients as well. So for example, if we look at nitrogen and sulfur applications, that typically where we use a nitrogen and sulfur grade, we have increased yields of between 10 and 20% where we use sulfur. So certainly, you know, continue to use sulfur, because that impact, you know, if you don't use sulfur, you're going to suffer a yield penalty, and that's going to then reduce the nitrogen use efficiency of any applied nitrogen. And the same with, you know, phosphate and potash, particularly on soils that are at low soil fertility. You will still need to P and K applications, because we usually look at, for example, at phosphate in springtime. There's a response to phosphate applications, and that response is greatest where soil fertility is usually lower. And then potash, we see response to potash applications of around about 4 to 6 kgs of dry matter per kg of K2O applied. So it's, you know, it needs a complete crop nutrition. It's not just nitrogen, and if we want to get, you know, maximize the return from that nitrogen, that high cost of nitrogen that if we're about to make decisions on purchasing nitrogen now, we need to look at the other nutrients as well. So I'd like to finish up there and now pass you back. Thank you.
Great, thanks to both Natalie and Philip there for some very clear presentations. And I think what they really do show is that whatever price you've paid for the nitrogen or about to, then need to drill into the numbers, do some careful calculations, so that whichever the price you paid, then you maintain that return on investment, because that's what it's all about, and keep that as high as possible. And then of course really do make use of all the tools and services out there, from analytical tools, the handheld end tester there that Natalie mentioned, but also then sending the samples, whether it's manures and slurries or any other product that you've got on the farm that contains nutrients, to get it analysed, find out what's in there, and then again really make the most of it in terms of where you actually apply it around the farm. So really optimise the use of all of those other manures and use them wisely. And then I think just finally, both Natalie and Philip mentioned there that we need to avoid those nutrients that might cause limitations. So particularly the sulfur there, really fundamental, but also other nutrients that are in the system. So make sure that they're not limiting, and then that will again ensure that that nitrogen that you've bought and paid for and applied is going to get utilised to its maximum and increase the nitrogen use efficiency. So with that in mind, then we'll now head into the Q&A session.